I got x is greater than 3. Okay. Number 3, that's my slope-intercept form, and then, of course, my answer there is graphed. And sorry, this answer is kind of in a bad spot. I got -4, comma, -6. I didn't plug that answer back in. Did you guys get the same thing I did? Okay. Mason, question.
I got a -32 and a +32, so to find out the y, I messed up on the adding 4 to 32 to get 36, but somehow I had -32.
Okay, let's check it out. So did you get, did you get this? Did you get x equals -4 for an answer? Okay, good. So it looks like you plugged back into the top equation.
Mm-hmm.
No problem. So if we did that, I'll just do this off to the left there. So it would be 8 times -4 minus 6y equals 4. That's if I plug into that equation.
Okay.
Does that make sense?
Yeah.
Okay. So then let's keep going. -32 minus 6y equals 4.
Yeah.
And then I need to add 32 to both sides to start getting that y by itself. So I'd go plus 32, plus 32.
I just, instead of, I messed up there.
Okay, so then when you do that, you get -6y equals 36. You'd finish with division. Okay. Okay, thank you for asking. Others, maybe a question on any one of these? Yeah.
Can you do number 1?
For sure. Okay, so number 1. So number 1, the instructions say solve, essentially, so get the x by itself. So, and it's kind of complicated, right? It's got some parentheses. It's got a lot of stuff going on there. So remember that if you're going to be solving something, before you try to solve it, you need to try to simplify whatever can be simplified first. So what kind of simplifying could we do? Anything jump out to you? Yeah, 2 distributive properties. Yeah, those parentheses are some hints about that. So I would say this would be 2x minus 18 plus 3 after we do distributive property. And then the 6 distributed would give me equals 6x plus 24. So far, so good? There's more simplifying, right? Did you notice that these 2 terms over here are like terms? So -18 plus 3 is -15. So again, all I'm trying to do here is I'm trying to simplify, because before I can do any of my awesome solving steps and techniques and all that stuff, all those properties, I've got to simplify first. The last thing that I see up there is the idea that I still have 2 different expressions, or 2 different terms that have an x. There's an x on the left side of the equal sign. There's an x on the right side. I need to simplify those. I need to get those together. But since they're on opposite sides of the equal sign, how do I get them together? What would be one way to get them together? Ray.
Add them or subtract them.
Okay, so you're right. We need to add or subtract to either side. So let's be specific on this one. What would you do? Go ahead, Noah.
Subtract 6x.
Okay, subtract 6x. So what would be an alternative? Instead of subtracting 6x from both sides, you could? Say again? No. You could subtract 2x. Like either way will get you to a good place. I'll go with Noah's because he said it first. But we could subtract 6x from both sides. And when I do that, I come up with -4x minus 15 equals 24. And finally, after all that simplifying work that I did, I'm ready to solve. Chase, are you okay with the simplifying part?
Yeah.
Okay. So now that we're ready to solve, I need to get the x by itself now. I've got a minus 15. I've got a -4. And as you guys know, what I used to do, and I don't do it very often anymore, is I'll draw like a little fence right through the equal sign. So you can kind of see what's going on the left side of the fence, what's on the right side of the fence. So how do I get rid of the -4 and the -15? What would you do first before I did anything else? Say again?
Add 15.
Add 15, yeah. Adding 15 to both sides of the fence makes perfect sense. That gives me -4x equals 39. And now I've got to get rid of that negative 4. And for some reason, it's not showing up. It's right there. You can see it on my screen. I actually wrote it. But why is it not up there? I don't know. How do you get rid of the negative 4? Division. It'll probably show up all in one shot. I feel like we're having some weird internet issues. I was trying to upload a video a few minutes ago, and it wouldn't do it. Okay. So there's our answer. So Chase, I feel like somewhere in there you're like, I got it.
Yeah, I was just,
Okay.
confused.
Okay, fair enough. Anyone else? Good opportunity to ask.
Is there any way possible you could do number 4?
Is there any way possible I could do number 4?
Yeah. Because I got y equals 10.
I think there is a way. So let's do this. So, Bray, would you put yourself in the category of you felt like you know what you're doing and it felt okay, but then you got a wrong answer?
I got the x right, but not the y.
Okay, so let's trace through this. So you did something like this. You got to x equals negative 4. You felt good about that, but now what? Okay, so why don't you tell us what you did, and we'll kind of trace through your steps and figure it out. So you got x equals negative 4, and then?
And I put the negative 4 and the 2x.
Okay, so you plug back in.
Yep.
So you use this equation.
Yeah.
Sorry, I never know if it's going to show up or not. Okay, so then what that should look like is this. 2 times negative 4 minus y equals negative 2.
Yep.
Does that look good?
Yep.
Okay. Obviously, you want to multiply. So you'd get negative 8
Negative 8.
minus y equals negative 2.
Negative 2.
Okay, so this is probably where we need to go. In fact, why don't I
Oh,
just
I see what
move this?
I added it wrong, guys.
So what did you add?
I added negative 8 to negative 2.
We need to add, so it's negative 8. So how do you move a negative 8 to the other side?
Positive 8.
You add 8. That's right. So you go plus 8,
So it's
plus 8. So it's negative y
6.
equals 6. We didn't want to solve for negative y, though. We wanted to solve for positive y. So how do I make that negative into a positive?
Subtract by negative.
Nope.
That's
Yeah.
That's what
Negative y is really negative 1 times y. And so division by a negative 1 would get you there.
Yep.
So you end up with
Negative
positive y
6.
equals negative 6. Absolutely. Anyone else? Okay, let's see here, our class started at 10:55. So you go till 11:45. Okay, so let me say this. We're like I said earlier, we're going to do kind of more of a traditional day as far as learning goes. But so it's 15 right now. If we get to 35, 11:35, if we get there and I haven't started to wrap it up, will somebody remind me, hey, it's 11:35?
Yes, sir.
And we need to wrap it up? Okay, cool. Good deal. Appreciate that. Okay, so here we go. We're going to do more of a traditional experience today. I hope that you guys did watch your intro video. I haven't checked that yet, at least in the last hour. So some of you might have done that in the last hour. Yes, ma'am.
Like, actually, I clicked the wrong button, so it says it's like a 0, but it wouldn't let me, like, retry it.
Don't worry about it. Yeah, don't stress about that.
Right. No, I like clicked that wrong.
She's talking about like the CFU at the end.
Oh,
Yeah.
yeah.
Yeah, seriously, don't, zero stress, please.
Okay.
You're okay. You're okay. So guys, I'm thinking that if you really did check out the intro video and learned a little bit from it, I'm thinking that number 1 might be doable for you. Okay? So what I'd like for you guys to do is I'd like for you to try number 1, and I'll just give you a moment, just a couple of minutes to do that. We'll see how it all goes. I don't think we're going to do all the examples today because we really don't need to. But we're definitely going to do this whole first page and maybe 1 or 2 from the other one. We'll see where we end up. But please try number 1. Square root of 14a. So you're on a whole different one. This is the intro video material. So
Oh, practice one.
should be on practice one,
Oh.
number one. Yeah. So guys, look at your paper, look at my screen, they should match. Number one should be square root of 14a times the square root of 2a.
So I'm still having trouble logging into Edpuzzle. So after this, could we try to figure that out? Because I don't know how.
So yes and no. So I have, basically I have to run down and get my lunch and come back up to here for something during like the second 2/3 of lunch.
All right. Yeah.
So I can't hang around right after class, but if you want to go get your lunch and then just come back up here a little bit later,
Yeah.
totally fine.
Thank you.
Okay. Wonder if anybody has any suggestions. What do you think this ends up being? Or like, what would be maybe a good first step? Like, what would you write down as soon as you saw that? Ellie, you had your hand up.
You do like the 14 treat multiplication.
I don't think we need to do that yet. I think that's doable, but I don't know that I would go there right now. We'll go there in a little bit. Mason, will you remove the earbud, please?
Yeah. Aren't they like terms, so you can just multiply 14 by 2?
So they're like radicals, yes? And so you can just multiply. So if you did do what you just suggested, what would be the result?
28. The square, like with the square root around it.
Okay, so square root. And what would go inside the square root?
28.
Isn't he really close, but not quite?
28 square a to the second.
28a squared. So yeah, getting the 28 in the radical is the right move
Why is it squared though?
because a times, so you've got
Because it's a times a.
you got an a and an a, so a times a is a squared. Y'all with me? Okay. So I think that now is when we would take Ella's advice and say, hey, let's take this square root of 28a squared and break it into its prime factors and see if it then simplifies. That make sense? Okay. So 28, anybody break that down into its prime factors?
4 times 7.
So 4 times 7, but 4 is not prime.
2 times 2 times 7.
Yep, so 2 times 2 times 7, that's 28.
And a times
And a squared is a times a. So this takes us back to the old square root simplifying that we've been doing last week and this week. I've got 2 2's and I've got 2 a's. So 2 2's come out as what? Just a single 2. The 2 a's, also a single a. What's the only lonely soul left in the radical? It's a 7. So it'd be 2a times the square root of 7. And that would be your final, most simplified, lovely version. You'd stop right there. Somebody said, wait, how does something happen?
Oh, Sasha.
Sasha, you get, or
Sasha, the gosh.
are we good?
Oh my gosh.
Okay. So number 2 is a little bit different. I don't know how you're going to handle it, but I'd love for you to try.
Yeah, I don't even know what it is.
So it's 12 times the square root of 5 times 4. And I will let you ponder that for a couple of minutes, or at least a minute. So we're doing number 2. Times the square root of 5 times 4. Yes, ma'am? Yeah, you can still get the same answer. Your idea was not wrong. Like if you kind of simplified first and then multiplied. I've just found people get confused by that. But it's Ella, it's not wrong, and if it doesn't confuse you,
This would just be times 20. 12 is the same.
Sure.
So I just have to.
Well, why would you take the 4 times about that?
Sorry, you've got what?
I don't know what I have to.
Well, why are you done so much?
I will have to make up concept is 12 minutes.
Just email me and let me know when you want to do that.
Okay.
Okay, we can go a lot of places with this. Anybody have something they want to offer? Like, hey, I think this is probably the answer on this one. Mason, you want to give it a shot?
Should I just go through my work or say what I got?
Well, I think you can kind of just do this in like a pretty brief answer. I really do.
I simplified the 12 and then the square root of 20.
Gotcha. So you did 5 times 4 is 20?
Yep.
Okay.
And then I did the factor truth out of 20 and I did 10 and 2 and then 5 and 2.
So you got 24 root 5 as a final answer?
No. Final answer I got 2 square root of 60.
2 square root of 60. Where'd the 60 come from?
12, that was in the first part.
Oh, you put the 12. Oh, I see what you did. You put the 12 in the radical.
With 5 times 2 times 2
Woo.
is 12.
So you can't do that.
No.
So 12 is not the same as square root of
Oh,
12.
so you just leave it on the outside and whatever. Oh, I see.
So,
I see.
bef-
Okay.
Yeah, but hold on. Before you get going too far, did anybody get something different?
I got right.
Anya, what'd you get?
I don't have big.
12 times 4.
Okay. So, Mason, I want to go back to something you said. And Mason, listen. Mason,
Yeah.
please join us fully here.
Joined. I am.
Leave your paper. Yeah, seriously, join us. You said something earlier, like when you first were talking about number 1. Remember with number 1, you said something like, those radicals are like radicals, so I can multiply them together. So this is really important for you to get. The 12 is just, listen please, the 12 is just a 12. Like the value of 12 is 12. The 4 is just a 4. Neither of those is a square root of any kind. The 5 is not a 5 though, is it? The 5 is the square root of 5. So, I've tried to color code it for you. The 12 and the 4 are both non-radicals. They're both non-square roots. So those can be multiplied just like some 4th grader would multiply, right? Now, they're not going to know what to do with the square root, but honestly, it's just 12 times 4. Please don't let that square root complicate things. The 12 and the 4 are both non-radicals. Those can be multiplied together. 12 times 4 is 48. The square root of 5 is just the square root of 5. There was no radicals for it to be multiplied by. So believe it or not, because 5 is prime and can't be simplified, that's it. That's it. 48 times the square root of 5, and you're done. You cannot multiply, not in the way you expect at least, you cannot multiply a radical times a non-radical and get what you think you would get. There is kind of a way to do it, but it's not convenient at all. And for us right now, there's not really a good reason to be doing that. Okay. Hey, you guys doing okay? Let me just remind you, any moments of temporary distraction are good reasons that you don't do well on quizzes. Are you with me? Even if I just look over at Noah and like, giggle, he, I'm thinking of something funny. Like, that's basically what some of you are doing right now. I'm well aware of it. I see. Like, it was interesting, Mason. I was like talking to you. Like, you asked me a question, and no, hold on. And this is actually a really important thing to think about. You should not be talking right now. It's so interesting. Mason asked me a really good question, and I'm actually addressing Mason, and he is giving me none of his attention because he's staring at Sasha, who's jacking around, distracting him. Am I right or am I wrong? So, listen, when I hand your quizzes back to you in a few minutes, and some of you are going to see that you made a 0, and you think, gee, why did I make a 0? Case in point. Do you get it? So I would recommend, listen, this is from a place of caring and love. I would recommend that if you want to do your best and learn, that you would not be distracted, that you would not be a distraction. Because God forbid if you say, gee, Mr. Anderson, if you tell your parents, I don't know, I'm just not learning very much, and we get to have that conversation with your parents, I'm going to have to say, you know what? I do actually have a problem getting Sasha's attention and Mason and, sometimes Bree this and Issa that, or whoever it happens to be. Issa, I'm just throwing names out there. Do you get what I'm saying? I'm going to have to say, I am actually doing a lot of good work here, and I'm trying to get their attention, but they are intent on being distracted and being a distraction, and that's probably why they have zeros on their quiz. Do you get it? I'm not going to pull any punches. I'm not going to play games. I'm just going to tell them and tell you exactly how it is. You screw around, you're probably not going to learn. It doesn't take a rocket scientist to figure that out. You pay really good attention, you have a good chance to learn. Again, it doesn't take a 300 IQ to figure that out. Do you get it? It's just coming down to you making the decision of, I'm going to be a distraction or be distracted or not. Get it? Okay, cool. So let's see if we can do a little bit better. Number 3. Again, I think if you're starting to get the handle on this with number 2, I'm thinking number 3 will go okay. So number 3, do you notice how there are 2 numbers that are not radicals? Which numbers are not radicals? And which numbers are in radicals?
7 and 6.
So, yes, the 7 is inside it. The 7 is inside a square root, Mason. I'll highlight it for you. The 7 is inside a square root. The 6 is inside a square root. But the 2 and the 3 are not inside square root. So based on that kind of reasoning and that identification, will you guys try to multiply, then simplify for number 3? That's why I said, will you try to multiply, then simplify? And it might be that you can't simplify. That's okay. Yes, ma'am. Go ahead.
Oh, it's the same thing.
So to decide, like if you're looking at it and you're like, I am not sure if that can be simplified or not, take the 42 and break it down. See what happens. See what happens.
So are you allowed to multiply radicals?
Yeah, you can multiply, and that's actually what we did in number 1, right? So we multiplied a square root times a square root and got that. You totally can do that. Yep. Okay, so when you are multiplying, you are very much allowed to multiply non-radicals together. So the 2 and the 3 would multiply to be 6. And then you are also allowed to multiply radicals together, like radicals. So square root of 7 times square root of 6 would be square root of 42. Now the question is, can you simplify that? In order to understand that, you might need to break it down. I think if you broke it down, you see 6 times square root of 2 times 3 times 7. And you notice how that there's no pair of 2s, there's no pair of 3s, there's no pairs of 7s. And so because there are no pairs of like factors, that means you cannot simplify it, and you would stop right there with that as your final expression. Okay, and you could list out either way. Like if you broke it down and listed that as your answer, it's fine. But I'd probably be better if you just left it as 6 root 42. All right, so I would like to try a couple more. We have about 5 minutes before I want to transition. So if you would, take a look at number 4. Yes. I think we'll do number 4 and number 5. Yeah, we'll just do those 2.
I'm actually kind of getting that.
Maybe you started to pay really good attention the last few minutes. This is good. Whatever it is, Mason, I'm glad you're getting it. That makes life easier for everybody. It's good. So this is going to get into our number 4. I'm kind of curious if you know this. Hey, listen. Focus, please. Yeah, just flip over. Number 4, you've got the square root of 7x plus 9, and then that whole thing is squared. Do you know how a square root and a squared interact? Like, what do they do? They cancel out. That's right, Trevor. And so you could just write, you basically just say this square root cancels with that squared, and you end up with just simply 7x plus 9. Okay?
So just pretend like it doesn't even matter that it's square.
So they basically, hey, let me put it to you guys like this. If I told you that your salary for the day was $200, and then I said, oh, you know what, I'll give you a $50 raise, but then you kind of screwed around and took too long of a break, and I said, oh, I have to dock your pay $50. it's almost as if the little bonus never happened, right?
Yeah.
So this is the same situation. You get the square root of 7x plus 9, and the very next thing we do is we square the square root. We just basically, it's just an illustration essentially of how a square root and a squared interact, like essentially what they do to each other. They cancel each other out.
So if it was like cubed, for example, would it be?
Now that's a little bit different. That would be getting into something that we don't do in our class.
Oh, okay.
But that's possible to work with that.
Yeah.
But we're going to keep it at this level for Algebra 1. When you get to Algebra 2, you'll do other stuff like that.
Okay.
Yep, for sure. Okay. Then our last one for the day then is number 5. When you, I'm really hoping that when you look at number 5, a particular property kind of jumps out to you. Do you see anything that...
11.
Distributive property, yes. Do you see how this square root of 11 right here? Do you see how that is being distributed through the parentheses? Okay. So, square root of 11 gets distributed here and here. And I'm going to write it out really in like very small steps here. So when I do this first distributive property right here, the first piece of it, wouldn't I get the square root of 11 times the square root of 11? Minus, and I'm going to do this other one, this other distributive property, the 2. Is the 2 a radical number or a non-radical? So when you have a radical times a non-radical, can you multiply them together and simplify?
No.
You can't really simplify, right? So the square root of, this is going to seem a little anticlimactic, but the square root of 11 times 2 is just this. 2 times the square root of 11. We can't multiply those together because the 2 is not a radical number. The 11 is. So we just have to say it's just 2 times root 11. There's a little bit more we can do here, and it's right here on this first term. What do you guys think the square root of 11, and they're both square roots, right? So what do you think the square root of 11 times the square root of 11 is?
132.
It's a square root of 121. So square root of 121. You guys are hopefully about to make a really cool connection, because it does say we're supposed to simplify. 121, is 121 prime?
Yes.
Yes, sir. No, sir.
Wasn't 11 and 11?
It's 11 times 11.
So it's not.
Oh, it's just 11.
So there's a pair of 11s,
So it just comes out as
and that pair of 11s comes out as what? As a single 11. What's left over inside the radical?
11.
No, there was 2 of them. They both come out as just a single 11. Technically, it's a 1. We could write that if we wanted to.
Why though?
So when you divide something, listen. If you divide something out, division by itself, don't you get a 1?
Yeah.
Not a 0? An empty radical means square root of 1. So that's why square root of 1. Now, what's the square root of 1? And what's 11 times 1?
11.
So the final answer here would be 11 minus 2 times the square root of 11.
No, it's just 9 squared.
Say again?
Is it 9?
No. This goes back to yesterday. Do you see how this and this
Oh,
are unlike terms?
Yeah.
Remember yesterday we talked about how you can add and subtract radicals?
yeah, I see.
Those are unlike radicals, so it has to be left like that. And this would be your final answer. Did anybody see how we could have done this a lot faster? We could have done this way faster. At what step could have we just basically answer? If you notice this, square root of 11 times square root of 11, isn't that just the square root of 11 squared? And what's the square root of something squared? Well, don't the square root and the square just cancel out? Leaving you with 11. So really, honestly, after this step, we probably could have just jumped right to a final lovely answer. But I wanted you to see these steps so you can kind of see why. That's it. Yeah, Trevor.
So you can't subtract 2 from 11.
No, because why?
2 and the square root of 11 are one thing.
Yeah, it's one term. So here, let me give you a parallel. So if I gave you this, Trevor, check this out. If I said 11 minus 2x equals 9x, wouldn't you cry foul there and say, no, you can't do that because they're not like terms, right? So this over here is really the exact same kind of thing.
Okay.
The 11 minus 2 root 11, they're not like terms. Any other questions? Okay, cool. So I would like to hand back your quizzes to you.